In this first application of the, or example of the application of the slope deflection method, we're ultimately going to go and find reactions, the shear and the moment diagrams, and a deflected shape for the structure. Our structure is a two-span continuous beam where the left span has twice the moment of inertia than the other span. They do have the same span lengths though. We have a distributed load applied only in the left span. We have a fixed end at the left, fixed end at the right, and we have a roller support. In terms of statical redundancy here, we have 7 total reactions, and that means with only 3 equations of equilibrium, this is indeterminate to the 4th degree. Whereas if we break this up such that we have member 1 to the left and member 2 to the right, then the only member end unknown displacement is the rotation right here in the middle. So let's call this A, B, and C in terms of the joints. So it's going to turn out that we don't know that theta in the middle. We know that theta A is going to be equal to 0. We know theta C is equal to 0. We know that there's no support movements up and down, no support rotations of any type, so we know chord rotations are also going to be 0. So that sets up really a slope deflection approach, but it helps us or informs us about how we might think about guessing what this answer is going to be. And we won't try to guess every last possible piece of this, but we'll try to get some idea of what we think is going to happen throughout the structure. Right? So for instance, the deflected shape is going to be such that, well, we've got no load in the right hand span, we only have it in the left hand span, so it certainly seems reasonable that the left hand span is going to move downward somehow, and because of the continuity over the support, that's going to want to attempt to cause the right hand side to pop up, but we have this fixed end here that's going to prevent that from happening. So I think that means that in the middle portion we're going to get a frowny face rotation happening, and I think we're going to actually end up with a rotation that is going to be clockwise or negative, and so that'd be my guess, that we'd have a negative rotation. Here's our little frowny face portion. Notice I'm going to use the, I don't like that very well. I don't like that very well because I'm going to use the bottom of the beam as my baseline for the displacement, and I'm thinking, how's that going to all get down to negative, or sorry, 0 rotation here? I haven't really got that set up well. Well, alright, so my approximation is looking kind of poor here. If I really think this is going to happen like this, I got to do something more along the lines here. You know, I can't have it kink over like that, so that means I've got to change this, get an inflection point in here, and then get something a little bit smoother. That's a little bit better. Still don't know if I really like it that well. I think I'm going to have, well, I know I have no rotation at the left, so that means a little frowny face so we can get the sag in there. It's got to drop down enough so that now I can come along and fit a little positive smiley face portion in here. Right? Not the greatest of anticipated deflected shapes. I got some mistakes in there, but this is a guess, so you know, get rid of this little piece in here that I decided that can't happen because I can't get it back down to where it's supposed to, but it is associated with the rotation that I'm guessing being negative or counterclockwise, and we got the sag in the middle. Right? Along with that, then, in terms of guessing some sort of reaction, what I might consider doing is look at extremes. And so I could come to this left side and say, well, if that were a propped cantilever breaking that moment continuity or curvature continuity at the middle support, I know in that case, in that extreme, that we have 3/8 of that load go to the right part, we've got 5/8 of that load going to the left support, the fixed end, and that we would get a moment after we go look at that of WL over 8 at that far left side. Problem with that, of course, is that it says I have 0 moment in the middle, and it says that I've got then nothing happening over in this right hand span. So that would mean that the deflected shape would look something like this, and I'd have a break in the slope because nothing would be going on in this right-hand span. So I know that can't really be the answer. The moment here would be equal to 0. So the other extreme that I might consider is to do two fixed ends in the middle. Let's say we think that that right-hand span is so stiff that we get effectively no rotation in the middle. And in that case, then we would get, of course, a deflected shape that would be symmetric. And I didn't draw it that way, but we get the moments at the end. Go look up the fixed end moments. That would be WL squared over 12 at both ends. And the shear reactions would be WL over 2. Well, that's interesting, but I don't think that's really what's going to happen. Why? Because take a look here. We've got the left span has a stiffness that equals 2I over L, and K of the right span equals just I over L. So K left is twice as stiff as K right. If this was reversed, I might think that might actually be that way, that the left-hand span is in reality looking at something that's pretty flexible out there. I think it's going to get a little closer to the roller than it is going to be to this fixed end. So a compromise out of all that is maybe an upper bound on this moment in the middle would be that moment is going to be less than half the average of those two, which is WL squared over 24. I think it might get closer to WL squared over 36. That might be my other guess. I don't have a good rationale for that. It's just I'm truly just guessing here. And that's the beginnings. I can now kind of play around with some of these reaction values. That reaction at the middle might be somewhere in between 3/8 WL and WL over 2. So that would be, I don't know, maybe 7/16 for that, maybe. So BY, maybe guessing 7 WL over 16. Not sure. I think that's going to be a little off, but we're getting kind of close, at least a little bit. And that's as far as we'll take it on the informed speculation. And we'll go figure out how to do an exact model now.